Hi dear students, once again I welcome you in my channel Mathematics Helper. I hope you like my videos, and if you like my videos, don't forget to press the subscribe button and the bell icon for latest notifications about videos. So we are going to discuss about question number 6 onwards from exercise 6.2 class 12th. See what is given in question number 6. There are 5 parts in it and I mark 2 only here. We will discuss after solving this, okay, our next 3 parts of this question number 6. Find the intervals in which the following functions are strictly increasing or decreasing. There are 5 parts, so in each part you will see a new function given. Let's start from the first part. So our first function given is let fx equal to x square plus 2x minus 5. First of all, write its derivative. Therefore, derivative of fx is 2x plus 2. As usually we write, we put our function equal to 0 and find the values. Our first work is to break whole interval into 2 different parts. The work is same here, but I will tell you one more method to find answer for increasing and decreasing separately. Here you want to find where our function is strictly increasing and where it is strictly decreasing. So we will write in this way. First of all, okay, write this as 2 common x plus 1. Write in the simplest form. Now for strictly increasing means we will start from the result. For strictly increasing, derivative of function should be greater than 0. It means its value, which is 2 into x plus 1, should be greater than 0. Or when you shift 2 there, 0 over 2 will be 0. So you will have x plus 1 greater than 0. In the end, x greater than minus 1. So on the number line, real number line, if I mark minus 1, here minus infinity and plus infinity. For this gap, for numbers greater than minus 1, means what are the numbers greater than minus 1? These numbers from minus 1 towards plus infinity. This function is strictly increasing. So we will say therefore from minus 1 to infinity, our function fx is increasing. So we will write from minus 1 to infinity, or our function fx is increasing for but minus 1 to infinity. Now it's opposite. For decreasing, for strictly decreasing. What is the result for strictly decreasing? For decreasing fx, derivative of f means f dash x should be less than 0, or 2 into x plus 1 should be less than 0, or we can say x plus 1 less than 0, or lastly x less than minus 1. And what is the interval then? Minus 1 is the value on the number line, but before this, what are the numbers? They are forming actually gap between minus infinity to minus 1. So we will say therefore fx is strictly, don't forget to use strictly word, strictly, here also is strictly decreasing. For or in you can use, in place of for you can use n, and in here in minus infinity to minus 1. So this is our first part of question number 6. See, next what is given in part number 2. Part 2 is also near about similar. I will do changes here. Part 2, and part 2 is having a new statement. So I am going to erase this gap, this portion, for writing answer of part number 2. See, part number 2 is 10 minus 6x minus 2x square. If we write its derivative, it will be 0 minus 6 minus 4x. Or in other words, we can say it is minus 4x minus 6. And if we follow calculations after this, okay, you can mark it as also write 2 common, minus 2x minus 3. So we have this. For strictly increasing, if you write strictly increasing, then derivative should be greater than 0, or 2 into minus 2x minus 3 should be greater than 0. When you shift 2 there, you can eliminate 2, so you have minus 2x minus 3 greater than 0. In other words, we can say minus 2x greater than 3 this can be written as, we can't shift minus sign directly in inequalities. We can multiply with minus 1 in both the sides. So it will be 2x, change the sign greater than into less than minus 3, or x less than minus 3 over 2. So for x less than minus 3 over 2, if I mark number line, real number line, suppose we have minus 3 over 2 here. For all the numbers less than minus 3 over 2, our function is strictly increasing. So therefore, fx is strictly increasing in minus infinity to 3 over 2 with minus sign. Now second calculation, for strictly decreasing, f dash x should be less than 0, or this statement which is 2 minus 2x minus 3 less than 0, or minus 2x minus 3 less than 0. Now shift minus 3 there, minus 2x less than 3. When you multiply both the sides by minus 1, you have to change less than into greater than. It will be 2x, in this side you have minus 3, or x greater than minus 3 over 2. What are the numbers greater than minus 3 over 2? This gap. So we can say, therefore, I am going to write answer of this. Therefore, fx is strictly decreasing in this gap between minus 3 over 2 and infinity. So this was part number 2. See, next what is given in third part, part C. Third part, which is part C, is given like this: minus 2x cube minus 9x square minus 12x plus 1. Since this is cubic, it will give factors as, when you write derivative, factors of derivatives will be actually factors of a quadratic polynomial. So better will be prefer the old method which we were using by putting derivative equal to 0. See how we solve it, okay, by the previous method. Let give it number name, okay, let fx. It is fx, which is minus 2x cube minus 9x square minus 12x plus 1. Write its derivative, which is f dash x. It will be minus 6x square minus 18x minus 12. And out of these, we can take minus 6 out. It will give us x square plus 3x plus 2. Just minus out from all, 6 out from all, you have this. And when you factorize it, factors of middle term are 2x and x. So its factors will be from first to x common x plus 2, from last to 1 common x plus 2 here. So its factors are x plus 1 into x plus 2. So you have this whole answer with us. So here we have derivative. Now what should I do to get answer of this whole expression? There is no interval given, but one thing is quite clear: we will write derivative equal to 0, which we did earlier in previous 1 to 5 persons, okay? So derivative equal to 0 means minus 6 into x plus 1 into x plus 2 equal to 0, which will give, when you shift minus 6 below 0, it will be 0. So x plus 1 into x plus 2 equal to 0. Then their product is 0, it means either first part 0 or the second part, means either first factor 0 or the second factor 0, which will give us two answers: x minus 1 or x minus 2. And they divide real number line into three disjoint intervals. When we mark them here, minus 2 in this side, minus 1. So their combination gives three disjoint intervals. They are minus infinity to minus 2, this one from minus 2 to minus 1, and lastly from minus 1 to infinity. So we will mention about these here. These values of x divide real number line into three disjoint intervals. What are they? Minus infinity to minus 2, minus 2 to minus 1, and minus 1 to infinity. Now we have to check for all these three intervals what kind of answers we have for this derivative. Derivative is here. So we are going to write now. So I am going to erase this whole, because I need only derivative. for first interval is, yes, minus infinity to minus 2. So what about derivative? Derivative is minus 6 into x plus 1 into x plus 2. Since this interval is up to minus 2, we can take any negative number. For example, if I take minus 3, minus 3 will give, here when we write minus 3 here, it will be negative. Here minus 3 when we write in place of x, it will be negative. So whole expression negative, negative, positive into negative, negative. So our answer will be negative, which is less than 0. So we can say therefore fx is increasing. Increasing or decreasing? It is decreasing because less than 0. In this interval, what is the interval? Minus infinity to minus 2. Now for the second interval, for minus 2 to minus 1. We will check derivatives value again. F dash x, which is minus 6 into x plus 1 into x plus 2. You can take any value between minus 2 and minus 1. For example, if I am taking value minus 1.5, minus 1.5 will show effect on only these values. Minus 1.5 will give, minus 1.5 plus 1 will give negative answer. Minus 1.5 plus 2 will give positive answer. So minus minus plus into plus plus. So our whole answer will be positive or greater than 0. So we will say therefore fx is, I used decreasing word, it is actually strictly. So you use strictly word, is here strictly also increasing in this interval minus 2 to minus 1. Now we will go for next calculation, which is about the third interval from minus 1 to infinity. So I will write for minus 1 to infinity f dash x. F dash x is minus 6 into x plus 1 into x plus 2. Minus 1 to infinity, you can take any value, like if I use 0, 0 will give minus 6 into 0 plus 1, 1 which is positive, here 0 plus 2 positive. So here you have negative, so our whole answer will be negative, which is less than 0. In other words, we can say therefore fx is strictly, for strictly decreasing we have it, okay, strictly decreasing in this interval from minus 1 to infinity. So this was part number C. See, next word is given in part number D. Here is part number D, which is given like this, okay, 6 minus 9x minus x square. Give it name that it is fx, which is function in x, which is 6 minus 9x minus x square. Then we will write its derivative, which will give 0 minus 9 minus 2x, or we can say it is minus 2x minus 9. Now it is linear, so we will prefer direct definitions. For increasing f dash x greater than 0, for increasing greater than 0, for decreasing less than 0. So we will write that, okay. For strictly increasing, f dash x should be greater than 0, or minus 2x minus 9, its value greater than 0, or minus 2x greater than 9. Directly we can't shift minus 2 there, we have to multiply first with minus 1. And when you multiply with minus 1, it will be 2x, and sign will be less than now minus 9, or x less than minus 9 over 2. If we mark it on number line from minus infinity to infinity, minus 9 over 2 will be, for example here, for all the values of x less than this, less than means for this interval, our function is strictly increasing. So therefore fx is strictly increasing in minus infinity to minus 9 over 2. Now for the other calculation, for strictly decreasing, for strictly decreasing, derivative should be less than 0, or its value minus 2x minus 9 less than 0, minus 2x less than 9, or 2x greater than minus 9, or x greater than minus 9 over 2. What are the values greater than minus 9 over 2? In this side, okay, that is from minus 9 over 2 to infinity. Therefore, fx is strictly, it is about decreasing. decreasing in minus 9 over 2 to infinity. So this was part number D. So this was also same as previous first part and second part done. Okay. Now we will go for last part, part number E of this question number 6. Students, in E part of question number 6 we have statement like this: x plus 1 raised to power 3 into x minus 3 raised to power 3. Let's write its name as fx, means function in x, which is x plus 1 raised to power 3 into x minus 3 raised to power 3. First of all, we will write its derivative, and that derivative is not that much easy as we did in previous questions all. So we have there are two parts, product of two functions. So if we use product rule, then we write first as it is derivative of the second, means derivative of this x minus 3 cube. So I will write derivative directly. 3 will come before, okay, this x minus 3 raised to power 2, power 1 less. Then derivative of this x minus 3 is 1 minus 0. Similarly, if we write first, I marked as it is derivative of second. Now second as it is derivative of first, it will be 3 in front of this, then x plus 1 with 1 power less, that is 2. Then derivative of x plus 1 is 1 plus 0. So we have x plus 1 cube into 3x minus 3 cube square plus x minus 3 cube into 3 into x plus 1 raised to power 2. From all these, see what is common. X minus 3 with 2 power common, x plus 1 with power 2 common. So I am writing x plus 1 with power 2, x minus 3 with power 2, as well as this 3 we can take out. They all are common. What is left inside? See what is left. One time only x plus 1 left, then plus sign, one time x minus 3 left. So we are having this x plus 3 raised to power 2, x minus 3 raised to power 2 here, and x plus x 2x, then 1 minus 3 will give minus 2. Or we can say it is 3 into 2 6. I am going to take 2 out. 3 into 2 6, x plus 1 square, x minus 3 square, then here it will be x minus 1. After that we put derivative equal to 0. So if we think about putting this value equal to 0, f dash x equal to 0, that means we have to put this 6 into x plus 1 square, x minus 3 square into x minus 1 equal to 0. Just think about values. Very first thing, it will be like this. So one by one, when you put all these equal to 0, so you can write either x plus 1 raised to power 2 equal to 0, or x minus 3 square equal to 0, or x minus 1 equal to 0. This square will eliminate and you will have only x plus 1. You will have 3 values of x. From here it will be x equal to minus 1. This will give square eliminate when you write square root of 0, and you will have only value 3. And when you write x minus 1 equal to 0, it will give x equal to 1. So there are 3 values. Therefore x is minus 1. I will mark them in order in this way, 1 and 3. So there are 3 values of x. Now these 3 values, if I mark on number line, these 3 values on real number line, they will divide the number line into 4 disjoint intervals. Firstly minus 1 here, then 1, lastly 3. There are 4 disjoint intervals. I will mention all these now, and for all these one by one we will see what kind of answer we get. It is strictly increasing or strictly decreasing. So we will write these 3 values of x divides the real number line into 4 disjoint intervals. What are they? First one from minus infinity to minus 1, minus infinity to minus 1. Second from minus 1 to 1. Third from 1 to 3, and the last one is from 3 to infinity. So one by one we will check answers of derivative for these intervals. For first interval minus infinity to minus 1. Our derivative is given here. It is 6 into x plus 1 raised to power 2, x minus 3 raised to power 2, and in the end you have x minus 1. Now we will check sign for this interval. It is from minus infinity to minus 1. You can take any negative number. For example, if I am taking minus 2, there will not be any effect on 6. Minus 2 plus 1 will give minus 1 because of square. You will get positive answers for both the brackets. For any case, every case it will be positive. But when you write minus 2 minus 1 will give minus sign, minus 3 or negative. So our overall answer will be negative or less than 0. So we will say therefore fx is strictly decreasing in this interval minus infinity to minus 1. Now we will go for interval number 2. For minus 1 to 1, we have f dash x given 6 into x plus 1 square into x minus 3 whole square into x minus 1. Let's take a number 0 in between minus 1 and 1 and think about their signs. If I write 6 as it is, 0 plus 1 will give positive sign, square will eliminate, okay, that whatever is the sign inside, whether it is positive or negative. Here it is square, so it will be positive. Here 0 minus 1 minus sign, or ultimately you will have negative sign less than 0. So you will say therefore fx is strictly decreasing in this interval which is minus 1 1. After minus 1 1 we have 1 3. So for 1 3 again write derivative f dash x equal to 6 into x plus 1 square x minus 3 square into x minus 1. So we have, firstly let's take a number between 1 and 3. Suppose it is 2. So 6 square will eliminate the sign whatever come inside, so they both will be positive. But the last number 2 minus 1 will be positive again. So whole answer will be positive, which is greater than 0. So we can say therefore fx is strictly increasing in 1 to 3. Now the last interval for 3 to infinity, f dash x, which is 6 times x plus 1 square x minus 3 square into x minus 1. Let's take a number, suppose 4 between 3 and infinity. So for 4, they both will remain positive because of squares. Last will also give positive sign, so ultimately your sign is positive, which is greater than 0 for the answer. Therefore fx is strictly again, okay, strictly, I am writing again, okay, this is strictly increasing in 3 to infinity. This was last part of question number 6. See, next what is given in question number 7. Students, question number 7 is show that y equal to log 1 plus x minus 2x over 2 plus x, x greater than minus 1. Remember it, your x is greater than minus 1, means all the numbers greater than minus 1, then is an increasing function of x throughout its domain. What is domain of this? All the values which are greater than minus 1, means all these values are making its domain. So let's start its solution. Right, y equal to log 1 plus x minus 2x over 2 plus x. Now derivative dy over dx. Log 1 plus x, its derivative is 1 over 1 plus x into derivative of 1 plus x is 0 plus 1. Then its derivative we can mark with the help of quotient rule. Square of the denominator, so it is 2 plus x square of this. Then derivative of numerator, which is 2x, its derivative is 2. Denominator as it is, then minus sign. Derivative of denominator, which is 2 plus x, its derivative is 0 plus 1 into numerator as it is. So this is derivative. Now it will be 1 over 1 plus x minus, it is 4 plus 2x minus 2x, which is like this, okay. So it is 2 plus x whole square So finally we can say here you have 4. I am taking LCM. LCM of two different values is their product only. So we have LCM. This will come here. It is 2 plus x whole square. And this will go there and get multiplied with 4. So 1 plus x. Next we have to solve it. A plus b whole square. A square plus b square plus 2ab will give this. Then minus 4 minus 4x upon 1 plus x into 2 plus x raised to power 2. So 4 cancelled, 4x cancelled. Ultimately we are left with x square over 1 plus x into 2 plus x raised to power 2. But we always write first derivative equal to 0. Now dy over dx equal to 0. It implies this value x square over 1 plus x into 2 plus x square equal to 0. It implies cross multiplication will give x square equal to 0 or x equal to 0. So x equal to 0, break this whole gap between minus 1 to infinity means domain into two disjoint intervals. First one minus 1 to 0, other is from 0 to infinity. We will check our function is increasing on these intervals. If it is increasing, we will say it is increasing throughout its domain. Domain means from minus 1 to infinity. So I am writing its calculation now here. I am going to erase it. So we have to write now derivatives value for first write okay. X equal to 0 divides the domain of y into two disjoint intervals. What are they? Minus 1 to 0 and 0 to infinity. So we will write now answers for both the intervals. For minus 1 to 0 first. What is dy over dx? Its answer is given here. Dy over dx is given here. It is x square over 1 plus x into 2 plus x raised to power 2. So what about any number between minus 1 and 0? Suppose it is minus 0.5. Minus 0.5 square will give positive answer only in the numerator. And minus 0.5 when you subtract from 1 0.5, okay, that will give 0.5 only a positive value. And here it is square, so whatever come, it will also be positive. So we can say our final answer will remain positive or greater than 0. It means, therefore we can say y is increasing in minus 1 to 0. Now for the other interval which start from 0 towards infinity. What is derivative? Again we will write derivative dy upon dx, which is x square over 1 plus x into 2 plus x raised to power 2. So any number you can choose from 0 to infinity. Suppose 1. 1 square will give positive answer in the numerator. Here also positive, 1 plus 1, 2 positive. And last also because of square positive. So final answer will remain positive or greater than 0. Therefore y is strictly, here I forgot to write strictly word, strictly increasing in 0 to infinity. Hence y is strictly increasing as given here throughout its domain. So remember, you have to remember this 7th important question for examination. Now see next what is given in question number 8. Here is question number 8. Find the values of x for which this statement y equal to x into x minus 2 whole square is an increasing function. The work is same again. So y is x into x minus 2 whole square in this way. First of all, multiply inside, it will give x square minus 2x raised to power 2 outside. Now write derivative dy upon dx. What is derivative? 2 will come in front of this. Inside x square minus 2x along with the derivative of this value inside, okay. Its derivative is 2x minus 2. So we will write 2 outside from these. So 2 into 2, 4. And what we left here? X from these two values, x outside. And here it will give x minus 2. And in this we have x minus 1. So ultimately we have 4x. X minus 1 into x minus 2. Then try to remember we always write derivative equal to 0. So dy over dx equal to 0 implies 4x x minus 1, x minus 2 equal to 0. Or we can say 4 when we shift below 0, it will be 0. So x into x minus 1, x minus 2 equal to 0. When we put one by one all these values equal to 0, either x equal to 0 or x minus 1 equal to 0 or x minus 2 equal to 0, you will have x0, x1 and x2. 3 values. So they divide. Here no information given about the interval, it means we have to consider full real number line. So these numbers, there are 3 numbers 0, 1, 2. 0, 1, 2, they divide whole real number line in 4 disjoint intervals. First is minus infinity to 0, then 0 to 1, 1 to 2 and 2 to infinity. So we have to check our calculations for all these, means sign of derivative on all these. So I am writing for first interval minus infinity to 0. We have to check only increasing. So we will find out greater than 0 answer for derivative. For infinity, minus infinity to 0, what is dy over dx? dy over dx is with us. It is here 4x, x minus 1, x minus 2. Let us consider a negative number between minus infinity and 0, suppose minus 1. So 4 into it, this x will be negative then. If I consider minus 1, then minus 1 minus 1, minus 2, which is negative again, minus 1 minus 2, minus 3 negative. So ultimately whole sign will be negative in the end when you solve it further, okay? So it is, therefore we can say y is decreasing. Y is decreasing in minus infinity to 0. Now for the other one, next one for 0 to 1. For 0 to 1, dy over dx, which is 4x into x minus 1 into x minus 2. For 0 to 1, use any number like 0.5. So it will be, x will be positive and 0.5 minus 1 will give negative, 0.5 minus 2 will give negative. Ultimately our answer will be positive, which is greater than 0. Therefore y is increasing. Y is increasing in 0 to 1. Next we will calculate answer for our next disjoint interval, which is 1 to 2. So I am writing for 1 to 2 dy over dx. What is dy over dx? 4x into x minus 1, x minus 2, their product. So we have to think about a number between 1 and 2. Suppose it is 1.5. So 1.5 is positive. So this x will be positive. 1.5 minus 1 will give positive. 1.5 minus 2 will give negative. So ultimately you will have negative sign which is less than 0. So we will say therefore y is decreasing in 1 to 2. Lastly we have for 2 to infinity. So dy over dx, which is 4x, x minus 1, x minus 2. Suppose we have a number 3 between 2 to infinity. So for 3, this x will remain positive. 3 minus 1 will be positive. 3 minus 2 will be positive. So ultimately our sign of answer will be positive, which is greater than 0. Therefore y is increasing in 2 to infinity. So we have only 2 times increasing, from 0 to 1 and from 2 to infinity. So we will write hence, in the end, hence y is increasing in 0 to 1 and secondly from 2 to infinity. So this is our required answer of 8. So thanks for watching the video. I hope you like the video. So if you like the video, please subscribe the channel and press the bell icon for latest notification. See you next time. Bye bye.